Hello everybody and welcome to 10 minutes learning from EduCounts. In this lesson we're going to discover together what are the properties of the exponents, especially rational exponents. We're going to discover how do you apply these rules and how we can use them to solve equations, in addition to how to convert from the rational expression or the exponent expression into the radical expression. So let's get started. So the first property that we have right now, which is a to the power of 0 is equal to 1. So any number to the power of 0 except 0 itself, would be equal to 1, and we will discover this later, why anything raised to the power of 0 except 0 is equal to 1. But right now we need to apply this property or understand this property. So if you have given any expression like x squared times by y to the power of 3, and then we have m to the power of n, all of that raised to the power of 0, so this is simply equal to 1. Okay, so this is how do you apply this property. Second property is negative exponent. If we have any negative can convert this form into 1 over a to the power of m, so to avoid any negative exponent in our expression. So for example, if we are given x to the power of negative 2, this could be written as 1 over x to the power of 2. On the other hand, if we have a negative exponent in as the denominator, in our denominator, we can raise this exponent up to avoid any negative exponent. For example, if we have here 5 over y to the power of negative 2, so this could be written as 5 times y raised to the power of 2. The next property is the power of power. If we have a raised to the power of m, all of that raised to the power of n, we can multiply m by n in our expression. So for example, if we have x raised to the power of 3, then all of that raised to the power of 4 is the same as x raised to the power of 3 times by 4. So this is the same as x raised to the power of 12. So the next property is the product of power property. So if we have a raised to the power of m times by a raised to the power of n, and we can simply rewrite this by writing just a and then add the exponents together. So for example, if we have x raised to the power of 2 and this is multiplied by x raised to the power of 3, this is the same as x raised to the power of 2 plus 3, which is x raised to the power of 5. But one more thing here we need to clarify is this property works only in case we have multiplication. So if we have the same base here in our expression and we have two different exponents, we can add them together. But if we have addition, this property does not work, because one of the common mistakes, some people saying that if we have a raised to the power of m plus a raised to the power of n, this could be written as a and then m plus n, and this is completely wrong. The next property is the power of product property. So this property says that if you have two numbers are multiplied together and the product of those two numbers is raised to the power of m, we can easily separate or find separately a raised to the power of m, then times that by b to the power of m. So for example, if we have here x raised to the power of 2 times by y raised to the power of 3, and all of this raised to the power of 5. So what we have to do right now, we can simply say that the first part would be x squared, this is raised to the power of 5, then times by y cubic raised to the power of 5, and then we can find every single one separately. So by applying the power of power rule here, so would be x raised to the power of 10 times by y raised to the power of 15. The property of power of quotient, it says that if we have any two numbers, the quotient of those two numbers is raised to the power of m, we can find or rewrite this expression by finding a to the power of m, then divide that by b to the power of m, in case b does not equal 0, since any number could be used in the as a denominator except 0, because if we have any fraction with a 0 denominator, the 0 denominator means this expression would be undefined. So for example, to understand this, if we have x raised to the power of 5 and then we have y raised to the power of 2 and all of this raised to the power of 3, so we can simply find this separately by saying that the upper part would be x raised to the power of 5 and then raised to the power of 3, and then we have y squared raised to the power of 3. After this, we can apply the property of power of power by multiplying 5 by 3. This would be x to the power of 15, and y would be raised to the power of 6. The property of quotient of powers says that if you have a raised to the power of m divided by a raised to the power of n and a does not equal to 0, we can rewrite this expression by writing a raised to the power of m minus n. So if we have here, for example, if we have x raised to the power of 5 divided by x raised to the power of 2, we can simply write 1x and then find the difference between 5 and 2. So this would be equal x raised to the power of 3, and a does not equal to 0, or the denominator here shouldn't be equal 0, since any denominator as 0 makes our expression undefined. The next property is how to rewrite or convert between radical expression and rational expression, or the expression with exponent. So first of all, we need to understand what is a radical expression. Radical expression, any expression has a radical symbol like that one, and the radical symbol here has some parts, like the number that below the radical is called radicand, like a, and the n number here is the degree or the index of this radical, and the whole expression is called the radical expression. So for example, here one of the famous radical expression is the square root of something. So this is a radical expression, since we have here the index is 2, but we don't write here 2. So simply, if you have a square root, you can understand that the index or the degree of this radical is equal to 2. But after 2, any radical expression higher than 2, we are gonna find an index written here like this one, the cubic root, and this is the fifth root, and so on. This property says that if you have any radical expression is equal to b, we can rewrite this by converting the radical form into the exponent form by writing b raised to the power of n, which is the index of the radical expression, and this gives you a. So in other words, we can here apply this with our examples, like if we have 7 and here we have the fourth root of 7, so we can simply say that this 7 could be written like this: 7 raised to 1 over 4. So since this 7, it has an exponent as 1, and the index of this radical expression is 4, so we can write this expression as 7 raised to the power of 1/4. On the other hand, here in example 2, we can write our expression 10 to the power of 5, and all of that under the ninth root by writing 10 and then writing an exponent as 5 over 9. Third example, as we don't have here an index, so we can understand that the index of this root is equal to, or the degree of this root is equal to, because this is the square root. So I'm going to write a raised to negative 3 divided by 2. Lastly, we have b raised to a, and all of that under the cubic root. So we can simply rewrite this by b raised to a divided by 3. And on the other hand, if you are given the exponent form or the rational form, we can rewrite this as a radical form by writing the radical root or the radical symbol, and then write this number, which is 7, and then I'm gonna separate the exponent by saying that this 7, the denominator would be the exponent of this number. So here we have 1, and 4 would be the degree of our radical, so this would be here 4. We can do the same thing here. We can write the radical symbol and then write the 10, and then we can say that the 5 as a denominator would be the power of this number, so this would be 5, and this would be the index of our radical form, so this would be 9. On the other hand, here, as we wrote a raised to the power of negative 3 divided by 2, we can simply here write the radical form and then write the a under the radical form, and then I'm going to say that the denominator would be the power of the a, so this one would be equal negative 3, and since we have here 2 is the degree of our radical, so there is no need to write 2. Finally, here, if we since we wrote b raised to the power of a divided by 3, so if we would like to rewrite this as a radical form, I'm gonna write the radical form like this, and then write the b below the radical form, and then I'm going to say that the denominator would be the power of the base, so this would be a, and the 3 would be the degree of our root, which is 3.